What's up, guys? We're back with another tricky type of circuit here. So I want to go over this type of jog circuit. And what I'm actually doing is I'm using another start button, because it's just a momentary button is all this jog is, in order to perform my jog function. So you're going to see a start button and another start button. Just understand that my bottom start button is my jog, just like it is in the diagram. Now, in order to make this work, I want to show you exactly what I was thinking when I did this. So if I had to illustrate this, this obviously is going to be I0.0. This will be I0.1. This will be M0, my first memory bit. This will be M0. This is going to be input number 2, because that's 0, that's 1. Here's input 2. This will actually be Q0.0. And of course we have M0 here because that's what we call that control relay. What I did in addition to this is I had to build another input circuit. And that input circuit would look something like this. A rung that goes to another memory bit that I'm calling M1. This would be input 3, and I'm using a single pole switch to perform that function. So when I hit that switch, M1 gets energized, and what I'm putting across that for this is that I'm going to use the overload that's in the circuit. I'm going to make it normally open, but I'm going to turn my switch in the on position, simulating an overload in the field, which will make that closed. So there is some tricky little things to see here. So in order to draw this circuit the right way, you actually have to create a rung that has this piece with the overload. And by the way, the overloads have to go before the coil. In PLC programming, it won't allow you to put an overload after the coil on the rung. So what I'm doing is I'm making this line, put the normally open, in my case, for my overload, because I'm going to use a switch and turn the switch on, just like a stop button. And then my MO. Then I have to duplicate this piece of the rung and come down and make my second circuit to here, and then make one more rung as an input. Let's see what that looks like. So if we take a look at my circuit here, and it's all labeled, you'll see that my start button is here. I hit the start, I'm energizing my MO. Now right now this is closed because my single pole switch is on. When a switch is on, it's a closed contact. So that's another input for me. So that's why this is made true. It'll energize this when I hit the start button. It's going to close this. It's also going to close this, which will still go through my overload and energize my coil. And it's going to be maintained because of that holding circuit. When I hit my stop button to de-energize that process or trip my overload, now when I come down to the jog, when I hit this, I don't have this closing anymore. When I hit this, I'm energizing the coil all by itself. And by doing that, because this is a momentary button, it's not going to stay energized. I'm going to keep bumping it. Now, let's just say my motor's on. When I hit my overload and I turn my single pole switch off, what's going to happen is I'm going to lose that M1. This is going to drop out, this is going to drop out, and I'll lose my coil. So let's see how that works. It's confusing, but you get the hang of it. You got to be able to draw the circuit. So here's where we're getting to the point where converting these ladder logics into PLC is going to start to get a little trickier, and you got to get creative. It's just one way of building it. So we've already transferred this circuit to save a little bit of time. What you're going to see is I'm going to hit my first start button so I can get the motor to start. So here's my start, and right now I hit it, my coil's energized. So now motor's running. But if I want to jog the motor, let's hit stop. This is going to be my jog button. If I want to jog the motor, you'll notice that as I'm hitting it, I let go. Right now I'm jogging it. I'm giving it that full voltage for short burst. So I'm able to jog the motor or make it turn a little bit. Maybe that conveyor moves a little bit. Remember that jog circuit? It moves a little bit, moves a little bit. So right now I'm jogging the circuit. Moving that conveyor, moving that motor just incrementally. And that's the jog. So now let's go and test the overload. So let's go here. Right now my motor's running. If I want to simulate the overload, I have to turn my switch off, which is the same as an overload tripping. It becomes an open circuit. So I'm going to turn this switch off and watch what happens to the circuit. It's going to drop out my coil. There you go. So if the overload tripped, we lost the motor, just as it should be. If the overload resets, we then have to go back and hit start again to get the motor, because when overloads reset, you lose your control circuit, which is the way it's supposed to be, and you have to physically go back there and see what's wrong, fix it, and then hit start again, and here we go. That's how it should work. Kind of a cool circuit. There's not many rungs. It just creates a little, you got to get creative, and that's what we're going to be trying to do in the classroom setting so that it's not a learning curve when we get in the lab. So hope you enjoyed this. See you on the next video.